Now we'll look at the fifth rule, which is the product rule. So in the product rule, you will see two functions of x that are multiplied by each other. So we will simplify it such that u is equals to one function of x, v is equals to the other function of x, two functions. Okay, what happens in the product rule is you are going to differentiate the first function of x. You're also going to differentiate the other function of x. Putting them together, you have your first function of x multiplied by your differentiated second function of x plus your second function of x multiplied by the differentiated other function of x. So they look like they swapped table mates. Now let's look at an example. Here we see y equals to x multiplied by 2x minus 1 to the power of 3. So we will have two functions of x here. This is our u and this is our v. So let me write it out. Now let's differentiate u. U is x, so we differentiate x to give us 1. To differentiate v, using the chain rule, we bring down the power to the front. The function stays. The new power is minus 1. Then we differentiate the function inside. So I'm doing this with the shortcut that I mentioned earlier in the previous slide. Alright, so using the product rule, u dv over dx plus v du over dx will be equals to u, which is x, dv over dx is 3, 2x minus 1 squared multiplied by 2 plus v, which is 2x minus 1 to the power of 3, and my du dx is 1. So I have two separate functions here, this plus this. If you notice, both of them have 2x minus 1 inside. So I am going to factorize out my 2x minus 1, and I can factorize 2 of it. So in my first function, I'll be left with x times 3 times 2, which is 6x. In my second function, I'll be left with 2x minus 1. So my final answer will be 2x minus 1 squared, 8x minus 1. Okay, now let's look at another example. So here we have two functions of x multiplied by each other. This is how we know that we need to use the product rule. So this is my u and this is my v. I'm going to write it out here. U is equals to x squared plus 1. My v is equals to 1 plus x squared. So let's differentiate my u first. Using power rule, bring down my power to x, and my power becomes 1. When I differentiate 1, I'm left with nothing. So differentiating my v now, using the shortcut that I mentioned earlier, I bring down the power to, the function remains, new power becomes 1, and then I will differentiate whatever is inside here. So I'll be left with 1 from x. So bringing out my product rule, dy over dx is equals to u dv over dx plus v du over dx. Now let's put everything together. My u is x squared plus 1 My dv dx is here 2, 1 plus x. And then plus my v here, which is 1 plus x bracket square, and then my du dx here will be 2x. So it really helps before you start your product rule to identify your u and your v first, and then you differentiate each of them, then you put everything together. So now let's simplify everything. So I have 1 plus x in both functions. So I'm going to just use blue. This function here plus this function here. So turn this off. Both of them have 1 plus x. So I'm going to factorize this out first. So from the first function, I'll be left with 2x squared plus 1. And then my plus sign. And in the second function, I'll be left with 1 more 1 plus x and my 2x. So simplifying this, I'll be left with 2x squared plus 2. I'm expanding this here. Plus 2x plus 2x squared. So I'll simplify it some more. I'll be having 4x squared plus 2x plus 2. Right, I should have taken out the 2 earlier. So now I will have 1 plus x. So in this function, I'll take out the 2, factorize out the 2. I'll be left with 2x squared plus x plus 1. And this is my final answer. Right, so now let's look at another question. So this question, I added in some surds, I've added in some square roots just to make it look a little bit more exciting. But basically, we are all going to do the same thing. So this is a function of x multiplied by another function of x. So this will be my u, and this will be my v. So writing it out, I have u equals to 2 square root x plus 3. And my v will be v equals, in square root, 1 minus 4x. Now let's differentiate u first. Before I differentiate, I would like to change my square root x to power half, just to make things easier for me. So I'm going to differentiate this using the product rule and the constant multiple rule. So the constant remains. I'll bring down my power. My x remains, and my new power is half minus 1. Okay, and then when I differentiate this, I'm just not going to get anything. So moving on, differentiating v. Now I'm going to change v to power half first to make it easier. So using the shortcut that I mentioned earlier, I bring down the power, keep the function. My new power will be the original power minus 1, and then I'm going to differentiate the function inside here. So I will have minus 4. So I'm going to simplify this so that when I put everything together, it will look nicer. So 2 times half gives me 1, so I'm not going to write that down. X to the power of half minus 1 is x to the power of negative half. So this gives me 1 over square root x. To make this a bit clearer. Okay, so simplifying this, I have negative 4 over 2 and 1 minus 4x to the power of negative half. To put them together, I will have negative 2 on top over square root 1 minus 4x. Now, using product rule to put everything together to get my dy dx. equals to u dv over dx plus v du over dx. We change table mates. Okay, so my u is 2x to the power of half plus 3. My dv dx is negative 2 over square root 1 minus 4x plus, looking for my v is 1 minus 4x to the power of half, and my du dx is 1 over square root x. Now let's simplify everything because they are like all over the place now. So I'm going to put this in a single fraction. So I have negative 2 times 2 square root x plus 3 over square root 1 minus 4x plus square root 1 minus 4x over square root x. So putting everything together, I'm going to do the denominator first. In indices and sets, we learned that we can put the sets together. So it's x 1 minus 4x. I multiply them together to make it a common denominator. So what I'm going to do here is to put in the denominator, which is plus I ran out of space. Okay, back to where we left off before I ran out of space. So as I mentioned earlier, they are two separate fractions, so I'm going to put them in a single fraction by multiplying the two denominators together to give me a common denominator. So when I do this, my first numerator on top here will have to be multiplied to the denominator in the second fraction, and my second, where is my mouse? And as for my second numerator, you have to be multiplied by the first denominator. So it will look like this. Square root 1 minus 4x Alright, so now they are in a single fraction and I'm going to simplify the numerator. So I have minus 2 square root x, 2 square root x plus 3 plus these two are square roots, so when I multiply them by each other, I'll be left with the function 1 minus 4x. So putting down the common denominator. Alright, so I'm going to do some expansion here. Minus 4x minus 6 square root x plus 1 minus 4x over the common denominator. So my final answer will be 1 minus 6 square root x minus 8x over square root x 1 minus 4x.